To find the degree of a polynomial, let's take two examples of algebraic expressions. The degree of this polynomial is 7. The degree of this polynomial is 6. But how do we know that this is 7 and this is 6? This is very simple. Highest power of the variable. This is the variable, x is the variable, and its highest power of this variable is 7. So this is the degree of polynomial. So degree of polynomial equal to highest power of variable. In this it is clearly visible that 6 is the highest number, and so the degree is 6 of this polynomial expression. Polynomials of various degrees are: first is linear polynomial. You can clearly see in this example that x is having degree 1. The highest degree of variable x is 1. That is, a polynomial of degree 1 is called a linear polynomial. A linear polynomial in x is of form. The form of this polynomial is denoted by fx is equal to ax plus b. In this example of polynomial expression that is linear, 5 is a and 7 is b, which is showing the standard form of the linear polynomial in x, and which is fx is equal to ax plus b. And you can see 5 and 7 in this expression are the real numbers. So a and b are real numbers. But a cannot be equal to 0. Second is quadratic polynomial. This is the example of quadratic polynomial. A polynomial of highest degree 2 is called quadratic polynomial. As you can see that the variable's highest degree is 2. So this is an example of quadratic polynomial. Hence, a polynomial of degree 2 is called quadratic polynomial. And the form of a quadratic polynomial, fx is equal to ax square plus bx plus c. This is our a, this is b, and this is c. And it is clearly visible that a, b, c are real numbers. But a cannot be equal to 0. These are mainly 4 types of polynomials of various degrees. In the linear polynomial, we have degree 1. In the quadratic polynomial, as explained earlier, we have degree 2. And in cubic, we have degree 3. And by quadratic polynomial, we have degree 4. And the situations for all these polynomials will be the same: a, b, c, or d, coefficients and constants, as these are coefficients and this is constant. Last one is constant. All these will be real numbers, and a will not equal to 0. Otherwise everything is the same except the degree. First one degree 1, then degree 2, degree 3, degree 4. Now we are going to learn about the number of terms in polynomial. If a polynomial containing one term, for example 5x square, what do you see here? Only a single term, one term here only. So this is an example of monomial. Second, if a polynomial containing two non-zero terms. What do you mean by non-zero? That is not equal to 0. That is non-zero terms. The value of these terms is not equal to 0, is a non-zero term. So a polynomial containing two non-zero terms is called binomial. For example, 3 plus 2x. You can clearly see that in this case 3 first term, 2x is the second term. The total term is 2. 2 terms. So this is a binomial polynomial. The same way, if an algebraic expression having 3 terms, for example, this is first term, this is second term, this is third term, then it is known as trinomial polynomial. Hence it is clear to you all. Now we are going to learn about constant polynomial. What is a constant polynomial? In earlier example of algebraic expression, I have shown you expressions like this: 3x square plus 2x plus 7. These have 3 terms. Suppose if I am not writing these terms, then what is left behind? Only a single term, 7. So I will write this single term 7 here. So this is only one term and it is a non-zero, not equal to 0, non-zero, and it is a constant. So a polynomial containing one term consisting of a non-zero constant is called constant polynomial. Examples: 6, 2, minus 1, minus 7 by 12. All these are constant polynomials. Zero polynomial. Last time I just wrote 3x square plus 2x plus 7 and I erased this first term, second term and left behind only 7, and this was the constant. Now in place of 7 I am going to pick 0 and let's see what happens. 0 clearly visible is only one term, namely 0. Previously I have explained that in the example of polynomial expression, if I put the value of a0, a1, a2, an as equal to 0, as the definition says that a cannot be equal to 0, and I explained why it cannot be equal to 0. If I put value of a equal to 0, what will happen? There will be no polynomial expression, leaving behind only 0. Put 0 here and yourself and you will see what you will be left with. So this will be equal to 0 and 0 is a one term. Hence definition: a polynomial consisting one term, namely 0, is called zero polynomial.